Algebra 1, Lesson 109, Advanced Trinomial Factoring. So, advanced trinomial factoring means we're going to factor trinomials with a coefficient in the lead term, like 2x squared minus 7x minus 15. So we're going to factor something like this. Now, there's two options here. If there's a 2 up here, maybe there's a greatest common factor, or we have to do some advanced factoring. Now, if I could divide all these numbers by 2, there would be a greatest common factor, and I could pull it out. However, I look at these numbers, and I cannot divide any of the other numbers by 2. There is no greatest common factor, so I have to go to advanced factoring. What advanced factoring looks like is we draw our set of parentheses. One of them is going to have a 2x and the other one is going to have an x, right? So the first terms have to multiply to create the x squared term, right? So 2x times x gives us x squared. Now what makes this advanced is this 2 is going to affect what numbers we put here, and it's going to affect what numbers we put here and which one goes where. So as before, if we just had an x and an x, it didn't matter if it was x plus 5 and then x minus 3. Here it does matter. The 2x has to have the number, has to have a specific number, and the single x has to have a specific number. So this makes it a little bit more complex. So now we're still going to look at this 15. We're going to look at the list of possible factors. So we have 1 and 15, and then we have 3 and 5, right? Now, since this is advanced and we've got a 2 up here, we also have to test 15 and 1 or 5 and 3. Now, you don't have to write them all out backwards, but as long as you know you have to try them both in reverse order, then you can do that as well. So there's actually 4 different variations we have to test, and here's the reason why. If I were to put let's see here. If I were to put 1 here, if I had, oh, sorry, I forgot about the signs. Sorry, last sign's a negative. So one's going to be positive, one's going to be negative. Now, since these are specific numbers and they're going to be different, I can't put the positive or negative yet. I have to test out positives or negatives in all of these. So this is going to be positive or negative, this can 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 be positive or negative, and this can be positive or negative. So what was 2 sets became 4 sets, and then since it's a positive negative is now 8 different possibilities for what numbers we put in here. So we have to think, if I put 3 as a negative here, or sorry, I was using 1. If I put negative 1 here, negative 1 would then multiply by 2x to give me negative 2x. If I were to put 15 here, that would multiply by x, and it would have to be a positive 15, so positive 15 plus negative 1 would be negative 14, or positive 14, that would not equal negative 7. So the goal here is, I know that once I put these numbers in here, one of those numbers is going to get doubled, okay? And then I have to know which one's the positive and which one's the negative. Now, since the middle term is a negative, it's a safe bet that the bigger number is going to be negative. So that could be 1 and 15, or it could be 3 and 5. Maybe. It's hard to say. So let's try it out though. So let's take 3 and 5, and let's say the bigger number is going to be the negative, which means that whatever times by 2 is going to be the negative. So if I put negative 5 here, and then I put positive 3 here, negative 5 times 2x would give me 10x. 3 times x would give me, or sorry, negative 10x. 3 times x would give me positive 3x. Negative 10x plus 3x equals negative 7. So it works out. So this is the correct answer. Now, these problems might take you a minute once you start getting the hang of them, because the only way to figure this out is just to use a cut and try method. Test different versions of these numbers until you find the ones that work. If you guys have any questions, let me know. I'll do one more example, actually. Sorry. Let's see if I can find one. Maybe I'll test all the possibilities on this one. Here we go. We have 3x squared plus 5x minus 2. So when this factors, I'm going to have a 3x and an x. because none of these are divisible by 3. And since the last sign is negative, there's going to be a plus and a minus, but I don't know which one is going to be. So look at the factors of 2. I've got 1 and 2. So there's not a whole lot here. And then they can be positive or negative since the last sign is negative. So let's go ahead and test all of these. I have to figure out when I take 3 times one of these numbers plus the other, which one is going to equal positive 5. So I'm just showing you all the different possibilities here. So that way you can see, how the cut and try method works. We just kind of pick one, see if it works. If it works, we use it. If not, we won't. So when it comes to positive 2, the factors are plus or minus 1, plus or minus 2. So let's say 1 was first. We've got positive 1, then we have negative 1. Then we'd have 2, and then negative 2. And then if this were positive 1, that would be negative 2. If this were negative 1, that would be positive 2. If this is positive 2, that would be negative 1. And if this is negative 2, that would be positive 1. So these are the 4 different possibilities I have just for the number 2. So if I did 3 times 1, that would give me 3. 3 plus negative 2 is going to equal positive 1. This one does not work. All right, let's try the next one. 3 times negative 1 gives me negative 3 this time. Negative 3 plus positive 2 is just going to equal negative 1. That doesn't work either. Okay. And let's see here. 3 times 2, that gives me 6. 6 minus 1, that equals 5. All right, hey, that's what we're looking for. We're looking for positive 5. So this is the winner. And then the last one, if we did this one, 3 times negative 2 would give me negative 6. Negative 6 plus 1 would equal negative 5, which is not what we want. Now, the good news is about these positive and negative problems, you'll notice that regardless of which sign is positive or negative, the number is still the same. You just have the positive or negative counterpart. So you can generally ignore the positive and negative values to get it back down to 2 versions. And then in order to get the negative correct, you would have to place it correctly inside of the polynomial. But since this is the correct answer here, positive 2 and negative 1, 3 has to multiply by positive 2, so positive 2 goes over here, and negative 1 has to be subtracted from the 3. So this would be our final factoring answer. If you guys have any questions, let me know on Moodle, and I will see you in class.